Yeah.
Okay.
Yeah, so, okay, so starting the review, typically when we're talking about what will and won't show up on the review, or on the exam, we're talking about the workout style problems. And so when I say like gravitation won't be on the exam, there won't be another workout style problem because we already had a gravitation problem on the midterm, which was unfairly hard. So,
Yeah.
there may be a question that shows up as multiple choice. I need to actually check the midterm because I try not to repeat things on the final that you had on the midterm. So, you guys
Review is always
It
good.
could be exactly the same.
So you did have gravitation, multiple choice on the midterm.
Why don't we just say it's not going to be there?
Well, I can say it's likely, most likely not going to be on there.
It's a
Good Lord.
probability function. Could be anywhere, anyone, anytime.
So definitely no workout problems. And then likely no multiple choice, let's say MC multiple choice. Either, okay, so that takes care of gravitation. Let's see, lecture 2. What was lecture 2?
No, I didn't bring it, all of it. I only took the part.
Oh, that was like static charges, yeah. Static charges, we talked about electric field. Did we get to electric force, or that was the next day?
I think
We
those
did
are-
do electric force.
Oh, we did?
Yeah, so that was electric force and electric field for static charges. Okay, so we had actually a lot of clicker questions from that particular topic on there already.
Yeah, and then we have the charged particle question on that one too.
Yes, you had the fixed particles, so probably nothing on the final from that lecture, because you've already been tested on it.
So no. Nothing. You're going to take a picture of this though, right?
Yeah,
Oh, good. So you remember.
yeah. I mean, we were building on these concepts, so of course we have to remember what electric
I
field
know.
is and use electric force, but when it comes to like the static charge pictures where you've got some charge.
You mean the multiple choice clicker things, or are you talking
Both.
workout
The
problems?
Workout
Okay.
problems were, yeah.
Okay.
So like the problems where you've got like a coordinate axis and you've got a charge here and another charge
Okay,
here.
okay, got
Like
it.
what's the field at this point? If
Right.
you have another
Oh,
charge,
good.
how
Alright,
would it
yeah.
accelerate?
Okay,
Yeah,
got
so
it.
those kind of questions.
Okay.
Okay. Lecture 3 was Gauss's law.
Right. Does it automatically answer your equations as you're writing with it?
What do you guys normally write? You're not talking to me, I know that. I don't care. Whatever.
Overpriced pins.
Okay, did we not have like a Gauss's law? So we didn't have a Gauss's law problem. The typical type of Gauss's law problem that I have put on the exam is like, here's some random charges and here's Gaussian surfaces that I've drawn, and what's the net flux through each Gaussian surface. That being said, Gauss's law is like the most theoretical thing we do, and as engineers, it's really not relevant to your life.
Yeah.
So
So what does that
So
mean?
it means like, I'm not overly concerned that I need to test you on it.
So it's a 50-50?
Well, I gotta look through the problems and see if there's anything I would actually put on the test.
No, I shouldn't say this, but so far there's like nothing on the final.
Nothing on the
So-
final. See, all I really need to do is pick at least one thing from pre-midterm that I can put on the final, because that's my general rule is, it is comprehensive, but it's heavily weighted towards the end of the term. So if I can find at least one thing from the beginning of the term to test you on,
You could say.
that's all that's really required. Gauss's law is like bottom of my list of like things that I want you to remember.
All right.
Well, okay, I'm gonna say workout problems, because I guess I could ask you a multiple choice question, and like I could show you a Gaussian surface and be like, what's the flux through surface B? We had a question just like that.
Right.
So that could, so
You
I'll
mean a
just say no
multiple
workout
choice?
problems.
No workout.
Maybe a multiple choice. Okay, lecture 4. Potential and capacitance. This is where we had a midterm exam question where you had to solve, you had to do the equivalent capacitance.
Oh, yeah.
And then you had to find the potential, so that pretty much covers it for capacitors by themselves. So I would say no workout problems, but maybe a multiple choice question. I really haven't done a good job of finding something to test you on.
I'm sure it's coming.
We have 9 lectures, so.
Yeah.
That's true. You've got a lot of stuff from the second half of the term that we haven't tested you on.
Wait, no.
So yeah, I would say for the first half of the term, your best bet is to study the clicker questions that we did.
Mm-hmm.
Because it doesn't look like I'm asking you to do any kind of workout problems from the first half of the term. So we did that static problem, we did the gravitation problem, equivalent capacitance, and the multi-loop resistor circuits.
And
And
no
that
mesh
was-
analysis, right?
Is
Not
that-
one of those.
Is that lecture 5? So we did lecture 5 before the midterm as well then.
Is that the mesh analysis one?
Yeah,
Yes.
we did do 5
And we
lectures.
did do a mesh analysis
Okay,
on
so
5.
that, yeah, that is pre-midterm. Okay. So you definitely won't see, you won't have the multi-loop resistor circuits. I could ask you like, maybe as a multiple choice question to find the equivalent resistance, though we might have already had we had a multiple choice one like this that said, you know,
Right.
resistors in series versus
Uh-huh.
resistors in parallel, what has the smaller equivalent resistance. I actually already asked you that. Man, you guys had a hard midterm. Like ask you everything.
I didn't notice.
I don't know.
We didn't bang our heads on the midterm.
Yeah. Well, we're still here.
Because there's nothing from that lecture
There.
either. I guess I wrote a very thorough midterm.
We'll just call it.
Sure,
good.
whatever you want to
Well, I mean, I guess what it comes down to is
Connect
like
the dots.
the ones where you might actually see multiple choices here and here.
So on lecture 3 and 4.
Yeah, and maybe here. This is likely no, but maybe. Right, so I mean, that pretty much narrows it down. You can study
Big
like
dot.
the multiple
Reading
choice
this
questions
tab.
from these 3 lectures, and then focus your efforts on problem solving from the second half of the term.
Yeah.
So lecture 6, that's post midterm. No, I
Afterwards.
skipped that. Lecture 6, yeah, okay.
We did that right.
Magnetic force and field. Okay. So we got lecture 6, 7, 8, and 9. So you probably can expect to see 4 workout style problems, 1 from each lecture. And then a smattering of multiple choice.
6, 7. So 6, lecture
6,
6,
7,
7,
8,
8, and 9. Okay.
Yeah.
Like that.
Yeah. So you're just looping that all together then at this point?
looping that.
I mean,
out
you're just
together.
saying right now, you just wrote lecture 6, so you just said basically
I like the look.
study them all?
I'm gonna go into more gritty detail. Now that I say you have a workout style problem, I'm gonna look at the problems you've seen already and tell you which ones are good ones to study.
Got it.
Make
Tell us
sense?
which one you're gonna use.
So, for
Maybe
lecture
get
6, let's
partial
see.
credit.
I said that example 27.6 is a good test problem.
27.6.
That rotating charges in a magnetic field.
Example
kind of
one,
thing.
the
Yeah,
one that was in the
example
worksheet?
26.7.
That was in the work, on the worksheet.
26,
27.6.
7.6.
And 27.24, I like that, that's that, you've got the velocity selector, and then it's like a mass spectrometer where it causes these rotating charges to come out the bottom.
Mm-hmm.
What did I just say that was? Problem.
27.24? Didn't you just say that?
Oh, no, that's the example.
That's example
That's the
27.
same example I just said. Sorry, is the picture was called 27.24.
For that kind of question, you'd show us the picture. You wouldn't just say
Yes.
a mass spectrometer.
I would
array.
give you a
Imagine if
picture.
you will.
Yeah.
Case in
Oh, okay.
Okay,
Oh, all
so
right.
problem 27.46, I say already, that's not a
As
good
you
test
see,
question. Example 27.4, I say not a good test question. I think pretty much any time we have the cross product where you had to look at the component form, I said not a good test question, because it's complicated, overly complicated.
Some teachers don't put that into consideration for tests.
Yeah, well, I try not to just-
Overwhelm us?
Yeah.
That's
Cross
good.
product.
That's why it's,
It's hard enough as it is. That's how I feel.
I agree. Good.
I don't know.
Let's get a really
Okay, so
complex
the homework
integral on
questions, the first homework question you had was 27.9. It looks like some of that required some of those problems required looking at the component form, so maybe I'll just say,
there.
Excuse me. Bless you.
like, the problems that involve solving for the magnetic force with all the components, those problems that,
So IE would be what?
well, there are some questions, like there's some parts of 27.9 that involve that. I'm not gonna say the whole problem is not worth studying, but those aspects of it.
Is, problem 27
Problem
or example?
27.9. I'm looking at your homework 7.
27.
Homework 6, problem 27.9.
P.
Oh, yeah.
27.15 is rotating charge, I like that. 27.22, rotating charge, I like that.
Are those examples or homework?
These are all homework problems, problem 27.15 and 27.22.
I just put star.
The crossed fields question, it's pretty much that problem 2730 is not enough work to constitute a workout style problem, but you might have a multiple choice question asking about crossed fields. And 2745 was pretty good, but it's a little bit hard diagram-wise. That one asked you to like draw a diagram of how the hinge is going to rotate, and it's like a three-dimensional concept. Kind of hard to draw for a test. Good one to study. It's like comparing the magnetic forces and then torque on a loop, but it's kind of hard to replicate that exact problem on the test. Because
So something similar.
similar, yeah, something similar to 2745. Okay. I think that's about it for that homework set. Oh yeah, 27.9 is wicked. I remember now.
Huh?
Is that a good thing?
No,
No.
that means
No, it's
wicked bad.
wicked
When she
bad.
says wicked, it means bad. Some people it means good.
No, I'm not that young.
Yeah, exactly. For it means bad. In other venues, it could be good. Some
Oh,
spots are
or I'm not from, yeah, I'm not from Boston. It's not wicked cool, it's
Oh.
wicked bad.
Okay, so now we're on to lecture 7.
Yeah.
Okay.
Magnetic fields due to long straight wires and solenoids
And
and
toroidals.
loops of wire and toroids. Toroids probably won't be on the test, so. Solenoids, long straight wires, 2 wires, the force on 2 wires that are near each other. Another one we did was like a long straight wire and then a square wire, and what's the force on the top versus the bottom?
Oh,
net
ABC, the one
force.
that where there were all, there was like the A field, the B field, and the C field thing.
No, I'm not sure exactly what you mean, but I mean.
That was a
So-
homework one we
Hello?
did. Or maybe that was different.
If you got like current like this, and current in this one that's going like this, then the force on the top would be bigger than the force on the bottom. And so, you know, like find the net force, that kind of question. Wait,
Okay.
we're in lecture 7.
Right.
So this was forces on long wires and solenoids, coils and solenoids, that's basically what we covered. So no toroids. I can't even spell toroids. Either that or my computer doesn't know the word toroid. Every time I write it, it's wrong. Spell check tells me I'm wrong.
Very odd. They can't do that.
It's because normal people don't use that word.
Probably. Thank you, I'm
Well, I mean,
okay, so example 28.3 and 28.5 are good ones to study.
Which one?
They're 28.3 and 28.5 are good to study, but they're
Physics or
probably
engineering.
too easy for a test. And then we had example 28.6, and you have to use that
Oh, I think so.
the harder equation for the B field at the center of a coil, but some distance away. So that's example 28.6. That's a good one to study. 28.44, solenoid kind of question. Problem 28.44. So this one's homework. Let's see. Oh yeah, 28.11. That was the horrid one that nobody liked.
yeah, I voted that one down. I think of it.
I think the one I
Which one
graded,
is it?
28.22, was reasonable. Problem 28.22. Mm, 28.32 just doesn't look like it would be enough for a test, just like study it, but we saw it on the test, there'd have to be a little bit more to it. 28.32. 28.38. Mm. 28.49, I graded that one as a good one. 28.52 is a toroid, so probably not 28.49. Plenty to study from these lectures. Switch colors, just for the fun of it. Okay. 8. That's the one we did last week where everybody was thoroughly confused by Lenz's law. How are you guys feeling now? You've had a week to simmer about this induced current stuff.
A little bit
I
better.
feel better.
A little
Yeah.
better, yeah.
I mean, it seemed like when we were doing the clicker quiz at the beginning of class, there was a more confidence in how you guys were talking about it. So, at the end of last week, it was kind of like, oh god.
Do we Sharpie letters on our fingers?
Yes, that's fine. I don't care. I won't consider that cheating.
Keep it tape.
Definitely doing
Mark on the tape.
So,
Maybe have little finger
I have a
puppets.
note for example 29.1 to skip part B.
29.1, which, so it's a pos,
So 29.1 was just a loop of coil in a changing B field, and you're to find the, what are you finding? EMF, the induced EMF, I think. And then, I don't know why I said, oh, changing it to an insulating loop. Yeah, that was the part where we're like, huh? That doesn't even make any sense. So, example 29.1, part A.
example 28.1.
I don't know, some of these are like, yeah, I guess so. What is this, induction? I don't know, like the ones where you're just solving for weird things.
Weird things.
Which ones?
Which
was that
weird
for?
thing?
Like 29.2,
We are in physics,
you've got
you
a
know?
loop of coil and you're using it to measure the Earth's magnetic field.
Oh, that
Like,
one.
engineers are gonna be like, what?
Yeah.
When we started actually, I don't know, I guess I can't really say that about the other ones. We're like pulling a bar along a rail, sort of random too.
Pulling ourselves along the bar, the rail of the bar, what?
That's Dave on Thursday. So easy.
You walked right into these things, you know?
That was an assist.
Okay, so problem 29.29 is all right.
29, 29 is 20, oh.
Yeah, that one, it's fine. I'm not wild about it. 29.29
Me either.
is better. More interesting, I guess I should say. More interesting. 29.29.
What is that?
I'm not gonna ask you guys about this average back EMF business. That was that example 29.3. That was like, what the hell? And 29.4, we're just deriving stuff. Okay. So what do we do on
I don't, did we
So
get,
no back EMF.
we didn't get homework back, right? Or did we? Did we get
I
homework?
did.
Likely no back EMF, or
Did I?
definitely?
I handed you back.
Oh, yeah, I got it, sorry. I just put it on
I
spot.
have Hannah's. You can hand that to Hannah. Okay. So your homework, let's see.
It's already studied.
Okay, so 29.2 is similar to the one that I was like, meh. I mean, find a study, but oh no, see, it asks about average back EMF. I just said I didn't want to ask you about that. What else? Oh no, that's not back EMF. So problem 29.2 and 29.5 are fine. Yes, not wildly excited about them.
Gotta find one that you were just passionate about.
I know. I am still looking. It could just be this section. It's like-
9.0.
Oh, there we go. I like these ones. Problem 29.15. I liked, and 29.20 similar. I'm more excited about those.
Those should get double.
When you say more excited, does that indicate that it's more likely gonna be?
Yes. I don't like writing boring questions. I mean, not like I don't try and write problems that you're just like, what? I mean, but I like,
I think we're always gonna say that on the task.
Like if I just have, I don't know. Yeah, if I'm not excited about it, I'm probably not gonna write a question like it. But it's good stuff to study, because those, the ones that I'm like, I mean, they're good concepts to build on, so you can do the ones that are a little bit more interesting. 2927, I like that kind of question. How did you guys feel about that shipwreck question?
No,
No.
No?
no.
Well,
It's just kind of weird. I don't know.
Oh,
If I was
all the
shipwrecked,
way-
then I'm gonna make like some
Once
kind
I
of
did it, it was like.
compass.
That's like Gilligan's Island.
Generator.
Professor!
Yeah, he would have been able to. do
All right,
it.
fair enough. Good.
It's
Fine
huge.
for homework, not good for a test.
Yeah, it's kind of a little.
Okay. Well, that's more than enough stuff from that lecture. Okay, this week's lecture.
Why'd you
Are
switch
you-
pens? Where's yours?
She
'Cause I
wanted
got
to-
bored.
Yeah.
I thought you said you liked 2920, or you're
Did
switching
I-
that one out with 25?
Oh, did I say 20?
Yeah, you said 2920.
I was just trying to remember what I said. It is 20, not 25.
Oh.
Oh, it's 2920. Oh, that changes it.
So, wait, 29.
There was there 25?
I don't know.
I
So you said
You
that
said
at one
no.
point.
20.
No, yeah, I said,
Yeah,
20.
I wrote 20,
okay,
because you
Oh.
said 20.
Yeah.
yeah. I just
I was like,
forgot
what
by
happened
the
to
time
20?
I
What,
walked
did
across
I write the
the
wrong thing?
Yeah, it's definitely 20.
Okay, so inductors,
Misplaced something.
so I'm not gonna ask you a toroid question, I already kind of said that earlier.
Yeah,
Where did I say
no
that?
toroids.
No toroid, so example 30.3 was asking about a toroid, so I'm not gonna do that. 30.4 was also asking about a toroid. I said when we did it, problem 3027 I liked, so basically, the part about the lecture that I liked was our RL circuits. So that's, you're most likely gonna see an RL circuit on the right. What was that problem we did? 3027 and activity 6.6. So another one is problem 3028. Problem 3028. Okay. So maybe a multiple choice question
What is that, EG?
from the LC or RLC, sort of like just those conceptual questions that we asked at the very end of the lecture. We had
Oh, the end of the
What is
stuff?
that, 6 point, what'd you say, AAG?
Activity.
Activity.
Oh,
6.6.
activity. Activity.
It's gonna be a hefty answer.
So any, I guess any questions about what you can expect then from the final? It's gonna be very similar to the midterm where you got one multiple choice problem with a bunch of multiple choice questions and then 4 workout problems. Just like the midterm, 2 hours, you guys can bring a sheet of notes with whatever you want on it. I posted last night the equation sheet that will come with your exam. So I have to change the formatting of it because it's like just barely 3 pages long, so I'm gonna have to try and smush it to 2 pages. But it'll show you what equations you'll be given, so you don't need to put those on your own cheat sheet if you don't want to. Anything I'm missing? Other questions you guys have? I will have office hours on Monday, so if you have any questions while you're
Be here for sure.
working through the homework, please come and visit. And otherwise, have a lovely weekend. State parks are free this weekend.
And you
Apparently
can fish
so
for
is
free.
fishing.
You don't need a license to